Alright, so in this video, I'll be showing you how to use the Newton Raphson method in Python. So we're given our problem here, which is to find the roots of the function x squared plus 2x minus 15 using the Newton Raphson method. So first, we want to define this function. So we do def f of x, return that as our function, so x squared plus 2x minus 15, which is this here. And next, we want to define the derivative of this function. So we set that as df of x. And the reason we do so is because later on, this will be used in the Newton Raphson formula. So we return that as the function of the derivative here, which is 2x plus 2, right? Because here x squared becomes 2x here becomes 2, and negative 15 is 0. Next, we set our parameters for the problem. First is the tolerance, and this is the same as the convergence criteria. So it's just a measure of how accurate our final result will be. And I set it here to negative 10, and you can set it to negative 20, negative 30, and so on, but your teacher will tell you what to set it to most likely. Next is the max iterations done by the computer. So how many times the computer will calculate for us. So I'm setting it to 10 here, and you can set it to 20, 100, 1,000, but the greater you set it to, the longer it will take normally. And next I'm setting the our first iteration, or I'm establishing our first iteration as the 0th iteration. So the first iteration the computer does is considered the 0th iteration, if that makes sense. But I'm going to show you this anyway when the results are printed. And then next we set our initial guess for the root of this problem, of this function here. So we just choose anything we want, but I'm choosing 1 here as my initial guess. So I'll write it down here as initial guess. And lastly, we set the result equals to f of x. And basically what this is that we're just evaluating this function here using this x value here. So what it means is we're replacing all the x values here with our initial guess value. So it becomes 1 raised to 2 plus 2 times x, plus 2 times 1 minus 15. So we just replace all the x values here with 1. All right, now you move on to the main part of our program using the while loop. So basically we write this down. While absolute result is still greater than tolerance and iteration is still smaller than max iteration, then the computer will continue to calculate. And what this means is that basically as long as the absolute value of this does not fulfill these parameters we've set here, the computer will continue to calculate and iterate for us. So here we write down iteration plus equals to 1, and I'll show you what this means very soon. And then result, as we've said, is f of x, and then we print this. So iteration here, itr, and result is result. And basically this statement will be printed when we show the results. And basically it shows the results at each corresponding iteration, which you'll see very soon. Next, we input the Newton Raphson formula, which is just x equals to x minus result divided by df of x. So this is the Newton Raphson iterative formula, which you can find on Google anywhere. Search it up, this will pop up. And this is the where the Newton Raphson part comes in. So I'll write this down here, and our formula. Afterwards, we write down if. So this is while. While means that as long as this is not being fulfilled yet, it'll calculate. But let's say if this is already fulfilled, then we write down this. If the absolute value of the result is already smaller than the tolerance, meaning it's already exceeded this, or is even better, then we can stop calculations, and we can print, that the value has converged to, and has converged to this value here, which is the x value here, the calculated root value using the Newton Raphson formula. And so I forgot to mention this, but anyhow, how this part of this program works is that when we find a new root value, the program will use that newly calculated root value that we found from the Newton Raphson formula and will evaluate this here, f of x. So just like before, whatever value we find here, we're going to replace those values right here. So it becomes So we're going to replace any x value here, and basically it just goes on and goes on and goes on until we fulfill these parameters right here. Whoops. And so lastly, if both of these if both of these have been written down, we have our final statement, which is else. And so if none of these two things happen above, then we can just simply say that, well, it did not converge. So we just write down did not converge. So with this, we can just run our program because it's finished, and we get that the root of this function here is 3. And so going back to these, so if you look at this statement here, print iteration itr result. So at this iteration, right, at this iteration here, it prints this result here, and same thing for iteration 2, prints a result here. So this is why we had this statement here, and also here. So let's say I set this to 1, the iteration will start at 2 instead. So that's why I set this to 0, and it's just a technicality basically. And here the itr plus equals to 1. It just here, just to make things clear, I'll set this to 2, and if I set this to 2, it becomes 2, 4, 6, 8, 10. So that's why I set it to 1. But basically, yeah, that's it. But of course, this is a quadratic equation. What is this? It's a quadratic equation. So there's 2 roots, right? We found the first root at 3. So there must be another root, and we just find the other root by changing the initial guess. So let's say I change this to -2, and I'll get the second root, which is -5. So that's basically it for the video, and I'll be sharing you the code in the description below. Thank you.